All right, we're going to start today with this warm-up on the board. This right here means we want that function f of x evaluated at 0. So I'm going to go through and replace all the x's with a 0. What's 0 squared? 0. Minus 25. Negative 25. I heard somebody mumble it. Great. What are your questions on that one? Part B is kind of like our warm-up from yesterday. We're evaluating a function, not just at an x value. It's still an x value. It's not a number, though. There's a variable attached to it. We do it the same way, though. We're going to replace every x with negative 3r. Anytime you substitute, especially when it's a negative number, keep it in parentheses. And then when we square this, the parentheses are going to change some things. So this is like negative 3 times negative 3, which is 9. R times r, which is r squared, minus 25. What questions do you have on the warm-up? All right, warm-up part 2 is just like the problems we were doing in class yesterday. So we want to find the slope first. I'm going to subtract my y values on top. I'm going to subtract my x values on the bottom. I'm getting 6 over 4, which simplifies to 3 over 2. That is my slope. What are your questions on the first part? The next one says the slope of a line perpendicular, no, I keep doing that, parallel to this line is what?
2 over 3.
Parallel.
Negative 2 over 3.
Parallel. Parallel, you don't change anything. You're doing perpendicular. Perpendicular, you flip it and then make it negative. So I might have thrown you off since I keep saying perpendicular first. I should just do perpendicular first. I don't know why I always want to do perpendicular first, but parallel is the easy one. You just keep it the same, and then perpendicular you flip and change the sign. What are your questions?
You might want to finish it out easily then. I think you want to do the hard one first.
Oh yeah, so I do the harder one and then finish out easy. Yeah, maybe I'll rewrite these next year. All right, now we are starting our lesson. Today we are doing section 2-3. It's all about graphing linear equations. All right, so today we're going to learn how to graph linear equations. I guess I should say we're going to review how to graph linear equations. This is something that should look very familiar. There are 2 forms we're going to work with today that the equation can be given to you in. The first one's standard form. So the most important thing to notice about standard form is this right here. The y value is not by itself. If y is by itself, we call it a different form. That's the next one we're going to look at. For it to be in standard form, the x and the y are on the same side, and then you have equals some constant. Other things to know about standard form, there's no fractions and no decimals in standard form. So if I ever ask you to put something in standard form, just make sure you get rid of all fractions and decimals. And then we don't want a to be a negative number, so be aware of that too. Any questions on standard form? Here's the other form we're going to look at today. It's slope-intercept form. Students are usually the most comfortable in this form. It's the one you see the most often. You can recognize it because now y is by itself. So if y is by itself, we want the equal sign, then the x term, then the constant. When it's in this form, y equals mx plus b, whatever is being multiplied by the x, that's your slope. And then whatever you're adding or subtracting on the end, that's your y-intercept. So this is an extremely useful form because you can graph very easily. The y-intercept's super easy to graph, and then the slope's pretty easy from there too. So students usually prefer this form. It's the easiest one to graph from. Does this look familiar? Okay, I'm hoping this is ringing some bells from Algebra 1. If not, that's fine too. So for these, to find the slope, we call the slope m. That's the number that's right in front of the x. And then the b is whatever they're adding or subtracting on the end. So I'll remind you of your form. We are in y equals mx plus b. So what's in the m spot for the first one? -5/8. What's in the b spot? 12. Good. So -5/8 is our slope. Positive 12 is our y-intercept. What about part B? It's our slope. 4. What's the y-intercept? -10. Great. Now, the special cases are kind of tricky. Thank you. If you are getting stuck on the special cases, if it's a y equals, I would encourage you to rewrite it with 0 times the x. If you think of it this way, what's my slope? 0. And what's my y-intercept? -8. Good. And if we actually think of the graph for a second, it is hitting the y-axis at -8, and it's going side to side. So that makes sense, right? Thinking back to what we learned yesterday about slope. All right, next one's a little bit trickier. We can't really rewrite it in y equals because there is no y here. Do you guys remember what the slope of this line would be? Undefined. Very good. And we can think back to what the graph's going to look like. It's going to go through the x-axis at 14, and it's going to go straight up and down. So does this ever touch the y-axis? No. So there is no b here. There's no y-intercept. Here's a couple more. We're trying to find m and b. The only problem is y is not by itself here. These are actually given to you in standard form. Now, when it's in standard form, there's really 2 ways you could graph it. Some people prefer to get it into y equals mx plus b. Some people prefer to do another method we'll look at. But for now, we're just going to practice getting y by itself. So how would I get y by itself on part A? Subtract 2x. Good. We want to move this whole term. It's positive, so we do that by subtracting. So we have y equals -2x minus 8. You always want to write the x next to the equal sign, and then the constant on the end. Now it's in the right form, so we can find the slope and the y-intercept. What's the slope? What's the y-intercept? -8. Wonderful. Questions? What about part B? What am I going to do? I'm going to get y by itself. Yeah, you want to get rid of the x first. So I'm going to subtract 4x. So I have -3y equals -4x plus 6. Again, we always want the x term right next to the equal sign, constant on the end. Now, y is almost by itself. I have one more thing to do. Yeah, this is where we divide. Good. And you're dividing everything on the right side by -3. So -4 over -3 is 4/3 x. Positive 6 divided by -3 is -2. What's my m? 4/3. What's my b? -2. Great. All right, next thing we're going to look at before we start graphing is the x and y intercepts. So if it tells you to graph using x and y intercepts, you have to find both. The way we find the x-intercept is we plug 0 in for y, then we solve for the x. For the y-intercept, we just do the opposite. We plug 0 in for x this time, then solve for y. So whatever intercept you're looking for, you replace the other variable with a 0. Now, x and y intercepts are very important because it tells us exactly where it hits the x-axis and exactly where it hits the y-axis. So let's say we did some math and I came up with the x-intercept is 4, the y-intercept is -1. I'm just making these up right now. So if it hits the x-axis at 4, I can put a point on my graph. If I know it hits the y-axis at 1, I can put a point on my graph. Now I have 2 points, so I can graph the line. So some people like graphing with intercepts. You only really have to worry about 2 points. Some people like slope-intercept form graphing. Some sections tells you exactly how to graph. Some you get to decide, so it's really up to you on some of these. Any questions on the idea of intercepts? All right, so we want to find the intercepts of 2x plus 6y equals 12. So I'm just going to make 2 columns. I want to find my x-intercept. I want to find my y-intercept. How do I find the x-intercept? Plug 0 in for y. So I'd have 2x plus 6 times 0 equals 12. Well, what's 6 times 0? 0. So you could actually, if you want, just jump right to this step. How would I solve that? Divide by 2. Great. So my x-intercept is 6. So if I was going to graph this, I would put a point on the x-axis at 6. Writing this as an ordered pair, the x value is 6. We already said the y value is 0. When you're answering these, I prefer them as ordered pairs. If you left it like this, I know what that means, but I would prefer that you take it all the way down to this step. Any questions on the x-intercept? How do I find the y-intercept? Yeah, I'm going to plug 0 in for x this time. What's 2 times 0? 0. So I'm going to jump right to 6y equals 12. So what's my y-intercept? 2. Great. As an ordered pair, the x is 0, the y is 2. Again, I'm going to make 2 little workspaces, my x-intercept space, my y-intercept space. Now, the y-intercept is really easy on this one. Why is the y-intercept so easy here?
0.
It's by itself.
Yeah, the y is already by itself, so what form is this in? Slope-intercept form. B in slope-intercept form is the same thing as the y-intercept. So what is our y-intercept here? 8. You don't even have to do any math. 8 as an ordered pair. 0, 8. However, the x-intercept is a little trickier from this form because when we plug 0 in for y, we'd have 0 equals 6x plus 8. So you kind of get an easy road on the y-intercept, but the x-intercept is going to be a little harder. To get the x by itself, we're going to have to subtract 8 from both sides, then divide both sides by the 6. When I reduce that, I get negative 4/3. As an ordered pair, negative 4/3, 0. This is one that students mess up a lot. They usually can get this part. It's pretty easy. If you forget that this is in slope-intercept form, you can still plug 0 in. You just get y equals 8 right away. Pretty easy. Students struggle with this side, so be careful on this. You do it the same way. It just takes a couple extra steps because you get 0 by itself. Questions? So when we are graphing, I told you the easy ones are when y is by itself. Because when y is by itself, I automatically know 2 things. I know the slope. I know the y-intercept. What's the slope here? 4. Good. I'm going to actually write it as a fraction because I want rise and run for slope. So I'm actually going to think of it as 4/1. What's my y-intercept? -7. Great. Now, we always start at the y-intercept. So I'm going to go down on my y-axis to -7, I'm going to put a point. From that point, I rise 4, I run 1. I rise 4, I run 1. So go up 4, run 1, you end up right here. Up 4 again, over 1. Once you have 2 or 3 points, go ahead and connect it with something super straight. A lot of students like to use the side of their IDs. And that's it. Any questions? If you're confused where to start, I once had a math teacher tell me that B stands for begin, M stands for move. So you begin here and then you move according to this. If that helps, great. If not, just remember you start with your y-intercept and you use your slope to find the next couple points. Questions? All right, here's the next one. So before we graph this, I want to find 2 things, my M and my B. What's my M? -2/3, great. What's my B? 6.5. Now, fractions tend to mess students up, but they're not really that hard. Instead of going to 6, we're just going to go to 6.5. Now, from there, I'm going to go down 2 spaces. So I'd end up at 5.5, then 4.5. So always stay on the halves here, and then we'll go over 3. Again, we'll go down 2 whole spaces, so from 4.5 to 3.5 to 2.5. And then we'll go over 3. Once you have 3 points, you could technically do it with 2. It's really up to you. Get something really straight. Connect them. And we're done. What are your questions? On this one, we're basically doing the same process in reverse. So we are going to write the equation of the line shown. So we need to find the M and the B here. And then we're going to rewrite it, y equals mx plus b. So what is my M? Anyone remember how to find slope when you're given a graph? You count the rise over the run. Good. So it looks like we're going up 1, 2, 3. We're going over 1, 2, 3, 4. So I rose 3, I ran 4. And what's my B? Where does it hit the y-axis? I heard someone say it. B is -3. B is just where it hits the y-axis. So now I'm going to rewrite it. I'm going to replace M with my M value, B with my B value. This is going to be y equals 3/4 x minus 3. What are your questions? We're going to follow the same process on example 8. We need to find 2 things. We need to find M. We need to find B. M is your slope, so count your rise over your run. I'm going down 4. Anytime you go down, it's negative. And then I'm going to go right 2. That reduces to -2. So my M here is -2. What's my B? 5. Great. Rewrite it. Y equals M x plus B. Any questions on this? All right, now we're going to graph, but it's in standard form. So there's 2 ways to do it when it's in standard form. The first way is to get y by itself and use M and B. The other way is to use x and y intercepts. So I'm going to show you x and y intercepts, just since we haven't done any like that yet. But really, it's up to you how you want to graph these. So on this one, to find the x-intercept, I'm going to make y 0. 4 times 0 is 0, so I just have 3x equals 12. Which gives me the x-intercept of 4. So I know I'll have a point at 4, 0. Y-intercept, we do the same process except now we're making x 0. So 3 times 0 is 0. So 4y equals 12. So my y-intercept here is going to be 3. So I also have a point at 0, 3. Once you have your intercepts, connect them with something super straight, and you're done. Now, I did say there were 2 options for how to graph these, so I'll show you the other option as well. You could start by just getting x by itself. So you'd have 4y equals negative 3x plus 12. Go through and divide everything by 4. So y equals negative 3 over 4x plus 3. Once you're in that form, we know we're going to start at 3 on the y-axis. Here we are. We'd go down 3, right 4. We get the exact same graph. It's really just up to you. Students a lot of times prefer getting y by itself just so you can do them all the same way. But the intercepts work here too as well. Alright, so I showed you both methods on the last one. Do you guys prefer one over the other? Anyone have a preference? Intercepts. Alright, good. I take requests. So I'm going to do the intercepts method here. So I need to find the x-intercept. I need to find the y-intercept. Graph them both. Connect the line. For x-intercept, I'm going to make y equal to 0. So I'll have 2x equals 6. X equals 3. So I'll have a point at 3, 0. Do y-intercepts the same way, except now you're making x 0. When x is 0, we'd have negative 3y equals 6. So y is going to equal negative 2, so I'll have a point at 0, negative 2. That's enough points to draw a line. And we're done. Did anyone get y by itself and graph it that way? If you did, you should get the same line. If not, one of us made a mistake, so we can double check. Any questions on this? These are the special case types of lines. So one of them is going to be straight up and down, one of them is going to be straight side to side. If you are confused, think about the intercepts. So y equals 5. That has to go through the y-axis at 5. So I automatically know that point. From there, what does it do? Yeah, y equals our horizontal lines. Good. So you either need to memorize that a y equals is a horizontal line, an x equals is a vertical line, or think back to the intercepts. This has to go through the y-axis at 5. The only way to do that without being the complete y-axis is to go horizontal. All right, what's the other one going to look like? Vertical, where? Negative 7 on the x-axis. So that's where I'm going to start, and then I'm going to go vertical through there. All right, so the y equals 5 is in black. The x equals negative 7 is in red. What are your questions? All right, that's all I have for you today. Here's your homework. Again, odds. Check the back of the book. Let me know if you guys have questions. We'll go over questions at the beginning of class tomorrow.